Hello. Okay, so we are going to start with our session. Just 1 second, let me check whether my voice is clear or not. Is it audible? Hello. Yes, my voice is audible. So, fine. So now I'll begin. So thank you for joining me today, and let's begin with our today's session. So let me remind you one thing. Since few weeks we have started this session, and today it's session number 5. If you have not attended the previous sessions, so below the link of this video, okay, I'll just quickly show you. So this is maybe you are watching, thank you for joining. And here below this video you will get in the description there is a link for the previous session. If you just open it, you will get all of the sessions, okay, one by one, and you can watch those. It means that you can watch the previous sessions as well. Another thing is that whenever we are attending these sessions, I am writing some notes here. Also, I am using some PPTs. Okay, so if you want to get the session notes and the PPTs, so you can join this Telegram group, amol ujagare .com/telegram. Okay, and you will get the notes just like this. Okay, so this is the Telegram group. You can install it on your Android mobile or whatever mobile you have, and you can also install it on your Windows, and you will see this group. So you can see the previous sessions also and the previous notes also. Those I have shared in this group. So you can just join this group by with this link only, right? So when you will open this link, you will have to fill up a little bit form, and then um, you will be joined. You will get a link to join this Telegram group, and once you are here, you'll have the access to these notes and other informative stuff too. Fine. So let's begin with our today's session. So in last few sessions, since we have started learning with the software testings, a lot of things we have learned, what a lot of things we have discussed, and today our agenda is to discuss black box testing and white box testing in detail. Okay, so before that, let me tell you why we are learning these concepts. So these concepts are necessary for the understanding of whole manual testing or manual testing as a whole. And very quickly, let me remind you why we need a testing. The testing is useful because whenever you create a product, whenever you build certain software, before going it into a customer's hand, it has to be evaluated first. All the bugs or errors, in case if it has, those should be resolved. Then only it has to be given inside, uh, then only it should be given to the customer. Because if you give any error a project or any product with lot of errors, then the customer will be annoyed, right? Because the product will be not as per their requirements. For example, if you buy any electronic application or anything that you buy, and if it does not matches with the expectation, then you will feel that we are fooled, right? So we have spent the money and we are not getting the things which what we expected. So similar way, in software testing, there are there is actually this important phase, that is the testing phase. Before going this product into the market, the product or the software is properly tested. Fine. So in last few sessions we have seen different development life cycles. So how the software can be built, what could be the processes. Then we have also seen the testing life cycle, how the testing can be conducted in various phases. And then we have learned the different levels of testings: unit testing, integration testing, system testing, and then user acceptance testing. It was quite reference to the V model. And now today we are going to learn black box testing and white box testing in detail, one by one. So let's understand what is a black box testing. So look at this. Suppose you have a software. Okay, so let's suppose this is a software. Okay, and let's say this is the interface of the software and this is the output. Fine, suppose this is a software and this is interface of the software, interface, and this is the result of your input. Okay, so what could be there inside the on the interface? Maybe it could be a login page. You can have, let's say, add user page. Then let's say this specific software, it belongs to, let's say, billing software. This is a billing software interface. So you will have login page, add user page, and let's say uh, add product, then add invoice. Okay, so different pages are there. So these pages, they belongs to this software. This software is internally designed and developed, might be using some different languages. And when you uh, when you use these pages to interact with this particular software, you get some result. For example, when you do login, you get, let's say, successful login. Okay, maybe you are successfully logged in. Okay, for example, let's say if you are doing the add user activity, so maybe you get the result as user added successfully. Then maybe if you are adding the product, then you might get a message like product added successfully. Now let me just show you this activity. I have one of the application which is quite like this, so let's see that practically. So suppose I'm opening this application. It is installed on my local machine. Later on I will also show you how to install this so that you can also practice this. So suppose this is a login page. Fine. So my first activity is to do and check and verify the login. So I am putting the correct username and correct password and clicking on login button. Okay, and I can see the dashboard here. Fine. So this it seems to be passed. And then let's say add a product. So this is a page product and I'm adding a product here. Maybe create a product. So when I will fill up this details and will save, it will add a product. Fine. And my journey of evaluating each and every functionality of it, for example, add customer, maybe add user, or whatever it is. So everything I'm going, everything I'm checking by evaluating this particular software, and everywhere when I put input I get some result, and based on that result I'm making some judgments. I'm writing some I've written some test cases. If I'm finding anything wrong, I'm reporting that as a bug. Okay, so all these activities that I'm showing and that I'm doing, do you see anywhere I'm interacting with any code, any source code? Because this application is built in PHP, and I have this software in front of me. I'm interacting with it. I am not at all bothered about what is the code inside it, how this software is built. Okay, for example, if you want to see, I have this software on my local machine and I can show you its code as well. So let me just go to its installation folder, and maybe somewhere here. So here there are some files, certain files. So I can show you some of the coding part of it. Okay, maybe here application configuration, libraries, core. So many folders are also there. Modules. Okay, you can see here modules. So different modules are there. So let's say clients module. So here you have clients.php. You can see its code. Okay, so somebody has written this code, so you can interact with the add client page, right? But are we interacting with this code? Are we checking any code? No, of course not. So although this software is visible to us, but its internal coding is not at all visible to us, right? So checking the software for its functionality, checking the software for its functionality without knowing its internal mechanism in the form of code is known as black box testing, right? So let me write the definition for it. So evaluating the software system, evaluating the software system externally, or let's say without knowing the coding inside it. Okay, so black box testing. Black box testing means you have this software, but you know, you are least bothered about its internal things. Okay, so it is you know, this box is black, so internally what is the coding, you don't see it, right? You just give the input and see the result. Okay, so this is called as black box testing. Okay, just one second. So this is what, this is a black box. Okay, and this is black box, and this is the black box testing. Getting this? So testing a software without knowing its internal coding details is called as black box testing. Fine. So now there are different techniques of black box testing we have. Okay, so different techniques are like error guessing, equivalent partitioning, boundary value analysis, state transition, use case testing, cause effect graph. Okay, we are going to see one by one. Maybe in the last class I have talked about the equivalence partitioning and the boundary value analysis. Today again we will revise them and we will solve different problems on it which are been asked in the STQB exam. So let's see one by one. Error guessing. So as the name suggests is that error guessing can be implemented by frequently evaluating the systems. When you frequently evaluate a particular system, you develop a certain ability to understand or to guess what could be what could be the different impacts of different operations. Fine. So that is the error guessing, and its definition, it says error guessing is a technique on guessing the error which can prevail in the code, and it is basically done by an experienced person uh, who uses a technique where the test analyst uses or who uses different techniques based on their experiences. Okay, so error guessing is experienced based. Fine. Then next one is the equivalence partitioning. Okay, so maybe a little bit explanation I have taken in the previous lesson as well, but here also we will learn this quite in detail, so that we will solve also different problem related to this which are asked in the ISTQB exam. So let's say equivalence partitioning. So what is equivalence partitioning? Suppose, let's suppose, okay, so what I'll do is I'll just make one note wherein instead of keeping it in notepad, I'll write it here so that I can maintain these images also there. Okay, so it is here. Fine, and just 1 second, I'll copy these things here. Okay, fine. So let's say the equivalence partitioning. Okay, now suppose there is a text box on a web page, and it is said that it can accept only, let's say, a 5-digit number. Fine, so it can accept only 5-digit number. Or shall we take some other example, or let it be, it can accept only 5-digit number. Okay, I'll take this example only. This is quite simple to understand. So 5-digit number means from 0 to 99999. Okay, so this is the maximum number, this is the minimum number, and this is the maximum number. Okay, so this is a text box which can accept the 5-digit number. Now again, we have learned that the exhaustive testing is not possible, because if you want to validate for this text box whether it accepts all these numbers ranging from 0 to 9999999, so it is actually not possible. Almost 1 lakh entries you have to make to validate each and every result. So what do? That we create some partitions. Okay, for example, this is the one and this is the one, wherein actually one of the partition is the valid partition. So I'll make this as a valid. So valid is what? So valid will be from 0 to 99999. Okay, so this will be a valid partition, means the values ranged inside this particular range so are valid from 0 to 99. So here there will be okay, I guess it will be -1. Okay, before 0 it will be -1, and after 99,999 it will be 1 lakh. Okay, fine. So this text box should not accept this -1. This text box also should not accept this 1 lakh. Okay, it should only accept the values ranging from 0 to 9999. So this is a valid partition and this is invalid partition. This is also invalid partition. Okay, now what boundary value analysis it says, that you don't have to check all the valid values or all the invalid values, just check the values which are on boundary. Okay, so for example, this 0 is there on boundary, this sorry, -1 is there on boundary, this 0 is there on boundary, this 999 there is there on boundary, and this is there on boundary. So just check these four values, that's it, which are there on the boundary. This is known as boundary value analysis. Okay, this is known as boundary value analysis. So let me just put this diagram into notes. So we are there here, let's say boundary value analysis. Okay, boundary value analysis. Fine. And now what equivalence partition it says. So in equivalence partitioning, suppose this is your same example. So here you see these partitions we have already made. So what equivalence partition it says, that take one value from this partition, one value from this partition, and one value from this partition. Okay, one value from this range of invalid partition, one value from valid partition, and one value from invalid partition. That's it. Okay, you just take these three and then you can validate your test. Okay, so this is the equivalence partitioning. So equivalence partitioning, what it says, let me write for boundary value analysis. So when you get the range of the inputs take or make and find the boundary values and pick up only the boundary values to test. Okay, then for equivalence partitioning, when you get a range of when you get the range, then make and find the different partitions and take one value from each partition. Okay, so this will bring you the equivalence partition values. Okay, one value from each partition. Fine. So this is boundary value analysis and this is equivalence partition. Now we will see one example from each. Okay, so just look at this. So last time also we have solved two examples, so let me just solve some another examples. Okay, let's search for something. If we find quite quickly, okay, let's search directly boundary. Okay, so this is one of the example, but this we have already solved. So next one, Yes, I got one. Okay. Yes, so this is one of the example, and let's do this for boundary value. One example we will do for boundary value analysis, and one we'll do it for equivalence partitioning. So remember, we have to learn white box testing also, and wherein actually there are also different kinds of example that you should understand and learn. So here we are. So this is the example of boundary value analysis. Okay, so I'll keep it here. Fine. So what it says, the input field can take the birth year between 9000 and 2004. The boundary values for this testing fields are. Okay, so let me just create a boundary or partition here. So two partitions. So what it says, that the field input field take fields between 1900 and 2004. Okay, so these are the valid partitions. So let's say 1900 1900 and second one is what, 2004. Okay, so this is the valid boundaries. Okay, and just after this it would be what, it would be 2005, and just before this it will be what, it will be like 1899. Okay, so these are the values on the boundary. So let's see what options do we have. Okay, so I'll just copy this and come back to the notes. Okay, these notes I'm going to share with you, don't worry, on Telegram group. Okay, so these are the notes. This is my range. So here 0, okay, 0 is not on the boundary, so there is no option of this. So 19000 2004, so this is actually a valid boundary. Okay, so this could be a correct answer. Then second one, 18991900, okay, this is also correct, and 2004 and 2005. Okay, so yes, so this is actually a quite more range of the values, so it could be quite more correct. And then this one, 18991900, this is fine, but 1901, this is not in the range, or this is not on the boundary. Even this 2003 is not on the boundary, right? So these are the boundary values, so I guess this C is more appropriate answer. This is also correct, but it does not takes the negative range. So let's just see. The answer is C, whether it is correct or not. So question number is 188, and I will just check its answer. Okay, so do I have the answer sheet? 188. So question number 188 is somewhere here. Okay, so 188 has answer C, means our guess is right. Okay, so answer is C. C is the correct answer. Fine. So this is the example for the boundary value analysis. So these kinds of questions may be asked in the ISTQB exam. Okay, one example we will see from let's say equivalence partitioning. So let me search one of the question from these questions I have already shared with you, where I have shared inside that inside your Telegram group. Okay, equivalence partitioning. Let me just search for few more. Okay, fine. Okay, so this is quite interesting. So we can just take this example for equivalence partitioning. After that, we are going to study few more techniques, black box testing techniques, and then we will learn the white box testing. Let's see how much we can complete. So here we are. So order numbers on a stock control system ranges between 10,000 to 999, which are inclusive, which of the following inputs might be the result of designing the test cases only valid equivalent classes? Okay, again simple, just create the range of it. So it is 10,000 and 99,999. Okay, so create a range, and here it will be 10,000, and then here it will be 99,999. Okay, and this is the partition. Fine. So this is the valid partition. This is invalid, and this is also invalid. Okay, so let me pick up this diagram and put it there so that we can compare with the options what we can have. So here we are. Below this we will put this diagram. So they are asking which of the following inputs might be the result of designing only valid equivalent classes. Okay, so the question they asked that we should have the values from only valid equivalence class, and the valid range is this. Okay, so all the values should be picked up from the valid in equivalence class. So let's just see. So 1000, this does not falls into this range. Okay, 1000, 5000, this does not falls into this range. So 1000 and 5000, they are less than 10,000. Then this 9999 also, it is less than 10,000. Okay, it does not falls in the valid range, so it is out of scope. Now 10,000. Okay, so 10,000 is here. Okay, then this is what? This is 50,000 and 9,900. This is I think it could be a valid equivalence class. Here we have one more range, one more option, that is 10,000 and 9,999, and this is also correct, but this would be a more appropriate answer because it has taken one more value. And now here you see 9999, which is actually less than 10,000. So I guess the answer would be C. Okay, so answer would be C. Is it correct or not? Let me just check. Okay, the question number is 227. Okay, so let me just go to 227. Yes, for 227 answer is C. Okay, C is the correct answer, which is this. Okay, so this is the correct answer. Fine. So this was all about the boundary value analysis and equivalence partitioning. So if you want these question papers, these are actually 500 ISTB question papers. I have downloaded it from net. If you want this, so I'll share. I have already shared today. Also, I will share it again on the Telegram group. So if you have not joined this Telegram group, you can join the Telegram group using this link, amolujagare.com/telegram. This is also available below the description of this video. And yes, now we are going to learn few more techniques from the black box testing. But up to this, if you are enjoying the session, if you feel that it is adding the worth or the value into your knowledge, then please hit that like button right now, and also share this link with your friends and colleagues so that they can also take this benefit. See, every Sunday, every Saturday, this time, that is 10 to 11, I regularly come live just for you. Just I want to help you in starting your career towards the inside the or within software testing, right? So in case if your friends or your colleagues, if they want to learn and understand the software testing or basics of it, or if you want to revise the software testing concepts, so please do subscribe to this channel and also join me on Telegram group. So share this with your friends and colleagues. Okay, and yes, so many people have some people have also hit the like button. Thank you for that. Now next one is actually one of the technique from the black box testing itself. So after equivalence partitioning, boundary value analysis, so this is a state transition. This is quite interesting thing. So here different states are being evaluated. Fine. So instead of directly going to this theoretical definition, let me show you an example. Okay, so this is an example of a state transition. So look at this. So here, this is the operation of the ATM machine, right? So this ATM machine is uh, having this ATM machine is having the different states. Like first you insert your card and then you enter the pin, right? First you insert the card, then actually machine will wait for you entering the pin. You will enter the pin, and let's suppose in first try if you have put the invalid pin, so you will get a chance to try for the second time. And if in a second time also your pin is not valid, then you will get a chance to enter the pin in the third time. But if even in the third attempt your pin entered is not correct, then your card will be blocked. Okay, so these will be the states. Suppose if in the first try itself you have entered the correct pin, you will get the access to your account. Or let's suppose if you are entering the correct pin in the second attempt, then also you will get the access to the account. Or even if at the third try, if you are getting if you are entering the pin correct, then also you will get access to your account. Okay, and this kind of activity is known as a state transition. Okay, so whenever you get some test case or you get some scenario, you draw certain states and you draw certain transitions. So based on this, when you have this state transition diagram in front of you, based on this you can you do the testings. Okay, so this is just one example. We will see few more examples. Let's say in this ISTQB exam paper itself, some state transition diagrams are there. Okay, maybe state transition. Let me just search. I guess at the top of it. Okay, so one of the state transition diagram is here. So many are them. So this is the question from ISTQB exam, which is very easy and simple. You can also answer it. Okay, so the next thing is, let's say, state transition testing. Okay, so state transition. So this is one of the example we have. Okay, I'll just reduce this diagram so that all the options we will have. So A, B, A, B. What are the options? Let me just check it once again. We have 4 options like this. Okay, A, B, C, D. Let me copy it proper way. A, then B, then C and D. In this way the options are. Okay, fine. So given this is a state transition diagram. Okay, so let's say there are 3 states. From S0 to S1 there is one state, from S1 to S2 0 there is one state, and these are the different arrows they are shown to go from one state to another state. So given the following state, so it is been asked that which test case below will cover the following series of the transaction. So let's say the transaction series will be starting from S1, then S0, S1, S1, S0, S1. So it's very simple. You can see that D and then A. Okay, so S1 to S0 can be traversed with the help of D, the pathway D, and then A. So DA, and then S2 DAB, and again S0 C. So DABC, DABC is the answer here. So I guess it would be a correct answer, DABC. So as simple as that. We'll see some other example also. This was very simple. So let's just check whether this answer is correct or not. So this is the first example, and the first uh, question, it has a answer A. Okay, so the answer is A, means our answer is correct. Okay, let's see something else. Okay, some other example. Yes, one more I got. Okay, so this is quite different and quite looks quite challenging, and let's see this example. Again, this is asked in the ISTQB exam. Okay, so what is this? Given following state transition diagram, which of the following series of the state transition contains invalid transition, which may indicate a fault to the system? Okay, so look at this invalid transition. This is the transition, so let's try to understand what it is. So it is login, then we are browsing, there we are creating a basket, then we are adding, going to checkout, and then we pay, and then we do logout. Okay, so what is been asked? Given the following state transition diagram, which of the following series of the state transition contains invalid transition, which may indicate the fault in the system? Right, so there are four options, and out of which we have to choose one of the invalid option. Okay, so we have to check one by one. So first is login, means this, then browse the basket. Okay, so you can jump to the browse the basket, and then you can, then it is said that check out the basket. Okay, browse the basket and then check out. Okay, login, browse, and basket, check out, and again basket, again check out, and then pay and log out. So this is quite looks like a valid one. Okay, the next one, let's see, login, browse, basket. Okay, login, browse, basket, and then check out, pay, log out. This also seems to be a valid one. Then login, browse, basket, check out, and then basket, and then log out. Okay, so here actually logout state is not there in this particular diagram. So when you are in basket, you may not see the logout. So I think this is quite invalid. Okay, but still we will check it. Still we will check it. Just one second. Login. The next one, login, browse, basket. Okay, login, browse, basket, then check out, pay, and log out. So this is also a valid one. So I think this is the invalid one. So let's just check the question. The question number is, the question number is 13, and the 13 number answer is C. So what we have chosen? Yes, we have chosen the C, and this is the correct answer. Correct answer means this is the invalid state. Login, browse, basket, checkout, basket, logout. Okay, so after basket we don't have direct logout option. Fine. So this is the correct answer. So these kinds of state transitions would be there. So the developer, or let's say the testers, they will draw the diagram of your operation, and based on those operations you can do your testing. So these operations written in the form of different states will be helpful for us to do the testing. Okay, so we have learned this type of testing. One few more we will see. Okay, so another one is use case testing, right? So you might have seen different in different projects. Actually, when they create a document, they create this use case diagram. So these use case diagrams are actually created with the help of, I remember in my college I used to we used to have this rational rows software, or even today lucid charts, or some other softwares are also there. So let's say lucid chart, I'll show you. You will have you can just use its free version also, and you can create the flowcharts of it. Okay, from somewhere here, so you can create the flowcharts like this. So if you'll just evaluate this, so you can you'll be able to uh, uh, draw the use case diagrams in case if you are interested. I'll just put this link, right? So let's say use case testing, okay, for drawing free use case diagram. So I am recommending you this lucid chart. There are some other examples as well. So uh, this is from here you can draw the use cases, but sometimes what will happen that most of the times you will have sorry, the use cases already given with you, and what you need to do is you have to write the test cases based on this use case. For example, in this use case, if you just see it carefully, so here this is the use case of a banking system wherein one user is there, one customer is there. Customer can do cash withdrawal, it can do transfer a fund, it can do a deposit fund, and these operations are done with the banking system. Before you do this, actually there is one operator also, or let's say the customer itself. Customer starts the system, customer can start the banking system, and then these operations can be implemented. Fine. So different test cases, like system starts, right? So looking at this diagram, you can write different test cases. What could be the tests we should carry out? So system charts starts. So here we can check whether the system is getting started or not. Then cash withdrawal. So if you are entering some amount and are you able to withdraw the cash, means the checks could be like when you will get the cash withdrawal, your amount deducted should be exactly reduced with your existing or the previous funds. Then transfer of funds. So transfer fund means in case if you have X amount of funds, and if you add let's say some additional amount of funds, so your new funds should be previous fund plus the added funds. Sorry, this is a transfer fund, right? So for transfer fund means you are transferring it to somebody else, right? So when you transfer, your fund should be reduced. And what I talked about, it was like a deposit fund. When you add the fund into your bank account, so the fund increases. Okay, so you can check that flow. So these test cases can be written with the help of this use case testing. Fine. And the last type of the testing technique, that is the black box testing technique, is the cause effect graph. Okay, so here let's suppose you are getting some issues. Okay, for example, you have some issues like server error. Okay, when you do some operations and you are getting some errors, server errors. We have seen this so many times. So generally what happens is that most of the times when your validations are not properly handled, so this kind of issue, it can appear. Okay, for example, if suppose this is a page, and suppose on some particular text boxes it is, let's say, allowing only the numbers, and if you are not entered number, if you are entered something else, okay, and this particular exception, or let's say this particular validation is not written by the developer, then sometimes it may occur that if you try to save it, it will not accept. And instead of giving us a proper error that please enter valid username, it is directly jumping to the server error. Okay, server error page, and this should not happen. So here effect is what? Effect is the server error page. What is the cause? The cause could be multiple. Okay, so one of the cause could be like entering the incorrect text inside the number, or let's say a zip code or telephone number, or entering some invalid value into some unexpected text box, right? So this could be the causes, and it could cause the effect. Okay, so this is also one of the technique, that whenever you are getting the certain issues, then you should also analyze what is the cause behind it. Fine. So this is all about the black box testing. Okay, again friends, if you are enjoying the sessions, please hit the like button, and also ask your friend to join these sessions. Every Saturday we come live at 10 o'clock, and the notes and the PPTs those I'm sharing with you are actually posted to this Telegram group whose link I've already shared with you. In the notes also, these notes also I'm going to share, and below the description of this video also the Telegram group link is there. You can join the Telegram group and enjoy the notes, enjoy the benefits of the notes and the PPTs. Fine. Now wait, we have not completed the session yet, so we are going to understand a little bit about the white box testing also. Maybe in detail we can learn about it in the next class. So remember, at the beginning of the session I've told you that let's suppose there is this software I'm testing. Okay, this is a billing software. It has different web pages we have, right? And as a tester, as a functional tester, what we are doing, we are just interacting with the web pages, and we are checking just what is the result we are getting, right? And based on result we pass our judgment, that is we post a bug reports or whatever it is. Now everything what we do without considering the coding part of it, we don't worry about the code written internally, right? And this technique is known as the black box testing. Now I am changing this perception a little bit more. So let's say when somebody develops a code, maybe at unit testing level or at integration testing level, the coding is also being tested, right? Sometimes as a tester or some different kind of tester known as white box tester, they do check the coding as well, right? For example, in this application, the login page application, this is hosted on my local machine, and I can show you the add client page code is like this. Okay, those who know this particular language, so it is written in the PHP, so they can go and check and different small model whether it is correctly written or not. Okay, so this kind of testing is known as white box testing, when the tester go and checks the real code of your system. Okay, so this is the code for add clients. Okay, so this is the method or this is the class written for the add client, and different steps or different functions and everything whatever you write here, it is actually responsible for the add client, right? So the one who goes and checks the coding part of it is the white box tester, and the technique of checking the internal code of your system is white box testing, right? So again, white box testing, it has different techniques with the help of we can check. So today I'll just name them, and maybe in the next class we will dig deep into it. So types of white box testings are statement coverage, branch coverage, and cyclomatic complexity. So these three we will see in the next class, that is on next Saturday. Okay, so in case if you have not seen or attended the previous session, so all these sessions link I have given already in the description. Let's say if you are watching this in this window, so you can just see in the description part of it, you can see previous session playlist. You can just open it and you can watch all the sessions, and you can please join also this Telegram group. So when you will join to this Telegram group, what will happen, all the notes and the PPTs those I'm sharing, that will actually be there with you, and also the notifications of the upcoming live sessions and the other important stuffs that I am posting on the YouTube, that will be also received to you. Fine. And one more thing, if you have not subscribed to my channel, please do subscribe it to it. Okay, so this is my YouTube channel, and I regularly post some important things related to the career. These live sessions are also there, but apart from it, there are different important videos, important stuff you have, right? So you can just make the benefits of it. Okay, so in case if you have not subscribed to my channel, please make sure that you subscribe to your channel and share this with your friends and colleagues. Okay, so that they can also take the benefit. Guys, this is free, and you can attend it for absolutely for free, and you can share this with your friends and colleagues, so that they can also take the benefits of it. Fine. So for today I'm closing the session. In case if you have any query, you can ask your queries, uh, you can ask your queries in the comments section. And what is your most important learning today, that also please put it into comment, right? So I read and respond to each and every comment personally, guys. So if you have anything to ask, anything to share, then please uh, share it in the comments. Okay, so I'm closing the session. Thank you very much, and we will meet on next uh, next Saturday. Thank you very much, and have a good day.